Okay, so until someone else arrives and has any questions, I'm going to go over the practice exam.
Okay.
Um, let's see. See if I'm able to
Yeah.
zoom in, right on it. Okay. Maybe I can make it larger.
Yeah.
There we go. Okay, so I'm just going to go through this thing. So rewrite as a decimal. I move the
Yep.
decimal place to the left. So there's an imaginary decimal point at the back. It's 40 point%.
Yep.
So I move it 2 times to the left. I end up with 0.40 or 0.4.
Yep.
If I do that here, then there is a hole. So it's 0.0525. Same thing on the 6.5%. I move it 2 times to the left, and I have a hole that I fill in with 0.065. 3% is like 3 points. I move that 2 times, fill in the hole, and I get 0.03.
Yep.
Writing percent from a decimal, you go 2 times to the opposite direction, so I end up with 8%.
Yep.
Moving it 2 times to the right, I end up between 1 and 9, so 1.9%. 0.32, I have the decimal point behind the 32, so it's 32%. And on the last one there, 2 times gets me between 0 and 6, so 0.6%.
Yep.
So far, so good? All right.
Yep.
So then the next section is the percent formula questions. I will just translate these into the formula and solve it. So my what is the thing I don't know, is equal, so x equals 45% is 0.45. Of means to multiply. 80. So 0.45 times 80 gets me 36.
Yep.
Okay, so Lacey, we're just working through the practice exam, and if you have any particular questions, you can let me know. So then number 10, 90 is equals 60%, 0.60. Of means to multiply, and this time we don't know what number it's multiplying. In order to get the x alone, it's multiplying, so I'm going to divide. And 90 divided by 0.60, I went ahead and worked out the calculator portions so that we wouldn't take up too much time with that silly stuff. It is 150. Number 11. 14%. 14% is 0.14. Of means to multiply, but we don't know what number it's multiplying, so x is means equals 560. In order to get x alone, it's multiplying, so I'm going to divide. And 560 divided by 0.14 is 4,000. Okay. So if you have any particular questions, feel free to chime in. If you want to send a message by chat, that's okay too. Otherwise, I'm just going to continue working until there is a concern. Number 12. Suppose the sales tax rate is 9.5% and a bicycle is $180. How much would the sales tax be? So sales tax is just percent of the price. So it's 9.5% of 180. So we're multiplying 9.5% as a decimal times 180. And when I plugged that into the calculator, it gave me 17.1. And I changed that to money. So I need 2 decimal places. That 0.1 becomes 0.10, or $17.10. The final cost, well, it's the 180 plus the sales tax that you have to pay. So when you add that, you get $197.10. 13, a computer is originally $800 but is marked for 15% off. What is the discount amount? So that's the percent off, the discount amount. It's 15% of the 800. So 0.15 times 800 gets us $120. And the discount amount is the amount taken off. So it started at 800 and you subtract off that 120, it leaves you $680 that you have to pay for this computer. Pretty good deal. Okay. Move you guys around. Number 14. Suppose a single guy with no dependents earns $41,000 from wages. Okay, so this is a lot of words. I'm going to help myself keep track. He's earning $41,000 from wages. He earned $300 from interest on savings. And I know that both of those contribute to his overall gross income. So his gross income, that's question A, is the 41,000 plus 300 so far. And then I'm going to go ahead and scan this and read to see if he has anything else going towards his gross income. He has a tax deferred account. That doesn't count towards his earnings. In fact, that gets deducted for his adjusted. His mortgage interest doesn't count. His state taxes were not earnings. Donations weren't. Personal exemptions and standard deductions, no. So the only earnings are this 41,300. So then his adjusted gross, well, I know that he gets to take off tax deferred accounts. So we don't have anything else that gets to be removed from the earnings. So the 41,300 minus the 2,800 leaves us with 38,500 for the adjusted gross. The rest of the items, the mortgage interest, the state taxes, the donation to charity, all of those are deductions that he could take itemized. So when I go to find his taxable income, I need to take that 38,500 and then I subtract whatever exemption he's eligible for. So the 4,050. And then I subtract deductions. Well, you have two options and you want to find out which is the best. So you can either take the standard deduction, the 6,300, or you can add up all of the deductions that he could claim and see if that's more money. When we add up the 5,000, the 900, and the 1,500, that totals 7,400 for the itemized, which is more than the standard. So we're not going to do the standard. We're going to subtract the one that's bigger. And when you do that subtraction, it should give you $27,050. Any questions, concerns? We're good. Okay. Then part D says to use the bracket below to find his income tax. So we know the taxable income. We'll use the bracket to find the percent amounts. So it was 27,050. The first thing that we need to know is which column he's in. He had no dependents and he's single, so he's going to use single filer. The first $9,700, he pays 10% tax. So 10% of the 9,700. And that is $970. But then from $9,701 to $39,000, which is more than he has, he pays 12%. So it's 12% of the rest of what he's earning. So the rest of what he earns is the $27,050 minus the $9,700 that he has already paid. So those of you just joining us, we are on the practice exam number 14. After I finish this one, if you want to ask a different question, go ahead, feel free. If you want to send a quick chat message, do that. So the 27,050 minus 9,700 ends up being whoop, that's not right. 18. Come on. 18,050. And 12%, 0.12 times that 18,050 gets us 2,082. So let's go ahead and erase all of that. So he has to pay the 970 and the 2,082. If we add up that amount, then we get $3,052 is his total income tax. Are there any questions at this moment?
Yeah, I got a question. You said the 27,050 minus the 9,700, 9,700, that's 18 and 50?
Nope, it is not. Double checked it. It is 17,350.
Okay, cool. I was making sure that I was like, man.
Yeah, no worries. And
okay.
Let's go ahead and plug in, make sure that the second. Okay, so the rest of the work is the correct numbers. 12% of 17,350 is the 2,082. From there, the rest of the math is good. Yeah, good question.
Okay.
Any others? All right. So number 15. So starting at number 15, this is section 8.3 material. From 8.3 on, there is a formula sheet that you should keep by your side. When I was going through this, I noticed there is one error on the formula sheet that needs to be corrected. I'm going to change it and replace the one that was already there, but it's a minor change for number 3. The formula 3 should say A equals P times all of the other stuff. Hopefully, when you're working through the problems, you would realize that, but I'll make the change anyway. Okay, so you borrow $20,000 from the bank at 4% simple interest for 5 years. How much interest? So the important thing is to be able to connect the questions to the correct formulas. It says simple interest, so I already narrow into formulas 1 and 2. I can either find the future value, that is the total in the account at the end, or the interest. Well, it wants the interest, so that's formula 1. I equals PRT. The principal here, the amount borrowed is 20,000. The rate, I always change to a decimal, so 0.04. And the time is 5 years. When I do that multiplication, I got $4,000. Number 16 is also a simple interest formula question. And A asks us to find the interest. So it's going to be the same formula here. Principal is $5,000. The rate this time is 9.5, which I changed to a decimal. And then the time is 6 months. But the time and the rate are now not matching up. So I need to convert 6 months to how many years it is. To do that, I can just take the months and divide by 12 months. Or you can realize that 6 months is half of a year. Either way. When you calculate that, it gets us 237.5 in my calculator. But since it's money, I go ahead and add that last decimal place and get $237.50. B, what is the future value of the loan? So now that is number 2 on the formula sheet. So it says A equals P times 1 plus RT. And if you want to plug in and solve that way, that's awesome. We'll do that. But there is an easier way for this problem. I'll go ahead and show the first way, and then I'll show the easier. So principal was 5,000 times 1 plus the rate times the time here, again, was 6/12, or 1/2. And when you plug that in, it is $5,237.50. But what you should notice is it's just the 5,000 from the beginning plus the interest. Because all that's happened to this account is you're putting in 5,000 and then the interest is increasing the amount. So it starts at 5,000, add to 37.50, and then you end up with that value. Either of those two would be accepted as work for this problem. So I like to not make things any more difficult than they need to be. 17. You invest $3,000 in a savings account with a fixed annual interest rate of 6% compounded semi-annually. That changes to 7% compounded quarterly after 2 years. What will the account balance be after 6 years? Okay, so there are really two different things happening at different periods. At first, for the first couple years, you have 6% compounded semi-annually. Well, this is going to be formula number 3, future value when compounded in times per year. So this is A equals, and there's that P that we need to plug in, 1 plus R over N to the NT. So the principal, 3,000. The rate for the first 2 years is 6%. Every time I write over that side, I have to move you guys around. Okay, so 0.06. In times, well, it's semi-annually. That's twice a year, so 2. So in times the number of years, well, for the first 2 years, that's clearly 2. When I put that into the calculator, it got me 3376.5, and I had to round it to the nearest penny. So I just rounded it to 2 places and got a 3 there. So that's for the first 2 years. But then the account changes. At that point, I have this as my balance. So that becomes the new starting amount for the next interest rate. So now when I go to do, and I'm going to write it out over here because I've run out of space. When I plug into the last 4 years, because we're doing what will the balance be in 6 years, I have a new principal of 3,376.53. And then I plug into that same formula, but now the rate has changed to 7%. And instead of being semi-annually, it's quarterly. So it's happening 4 times a year. Raised to the n times t, well, for this portion, it's the last 4 years, so 4. And that gets us 4,456.78. Now, I'm going to give you guys the answer key uploaded to Blackboard, but for right now, what you should really focus in on, more than trying to furiously copy all the numbers and make sure that I entered it into the calculator correctly, maybe I did, maybe I didn't, doesn't really matter. What matters is, do you understand the logic, and could you do this with another problem with different numbers? So that's what you should question, and let me know if you have a concern with. So B then says how much interest was earned after 6 years. So so I didn't make it a separate formula. So the interest is, I put $3,000 to start, and then I did nothing else to the account. So everything else that is in there to make up that 4,456.78 is interest. So if I take the total, 4,456.78, and I subtract the amount that I put in, 3,000, the rest of it is going to be interest that was just given to me for letting it sit there. So that is $1,456.78. Any concerns so far? Okay, good. Let me know when there are. 18. Suppose you begin saving for retirement at age 25. And I know that not everyone is 25. You can just forgive me for that sort of thing. You decide to deposit $100 every month into an IRA at an interest rate of 4% per year, compounded monthly. How much money will be in the IRA when you retire at age 65? So this is an annuity. You are depositing every month and you're trying to accumulate savings. That is an annuity. It is the formula number 6 on the formula sheet. So this is number 6. And the value of the annuity equals P times, and you'll notice I have this formula sheet, not just because I don't know the numbers, but I don't have all of the formulas memorized every little piece. I just don't. There's no reason to. Keep the formula sheet by your side and use the one that we need to. Okay, so 1 plus R over N, raise to the NT, minus 1, all over R over N. Okay. So the P here is the amount that you are depositing periodically. That is $100. The rate was 4%, said monthly. So that's 12 times. And the number of years, well, if you start at 25 and you end at 65, that's 40 years. Minus 1. All over R over N. When I plug that into the calculator, I'll tell you, I've had students email about plugging this into the calculator. My recommendation is, if you have your TI-84, to plug it in literally piece by piece as it is right here. So if you just plug in all of the parentheses and the division symbols in the right order, it will get you the right answer. But if you don't have TI-84 for whatever reason, maybe you were you got one from the tutoring center, but then get it back. I don't know. But what you can do is work piece by piece. One thing that'll make this a lot simpler is if you do the numerator and denominator separately. That could simplify it for you. If you do the parentheses together and then raise it first, do order of operations, that's fine. But the hands down easiest way is plug it into the TI-84. When you do that, I got 196.13. And of course I had to round it. Okay, B says, how much did you earn in interest? So I did make this one a separate formula. The total interest on annuity equals the value, which we just found, minus the total of all payments. So it's that 118, 196.13 minus, well, how do I find the total of all payments? Each one was $100. And then I deposited 12 times a year. So for every year, it's going to be 100 times 12, 1200. And then there are 40 years that I'm doing this. So multiply by 40 and you get the total. So when I plug in the expression in red, I am left with $70,196.13 as the amount of interest that I earned by putting those deposits in. That's a free $70,000, $100 every month. It's probably wise to do some sort of savings like this if you want free money and you want to retire big. So get started on that if you haven't. Any questions or concerns at the moment? All right. Then number 19 on the practice exam. If you want to save $50,000 and make regular, I noticed when I worked this out just before we started this, there were two errors with this question. That, and then also I left off how many years you're going to do this, which is really important to solving. So we're going to have to add that. But regardless, we're going to make monthly payments to an annuity that pays 10% compounded monthly. How much would you need to deposit every month for 5 years? So if we're doing this for 5 years, how much do we have to put in to get to 50,000? So this question is formula number 7 on your sheet. Now, instead of the value of the annuity, we want to know what are the payments that you would have to make. So that P equals A times R over N over 1 plus R over N to the NT minus 1. So A now is the final value, which I want to be 50,000. The rate, 10% or 0.1, 0.10, whichever. And in times, it's monthly, so 12. 1 plus R over N. And it was 5 years, so times 5 for T, and then minus 1. When you enter that expression into the calculator just as it is, it should give us $645, and then rounded 69 cents. So in order to get $50,000 in 5 years, I have to make deposits of $645. Okay, last page of the practice. And no more mistakes. You want to buy a house that costs $200,000. The down payment needs to be 10%. And the rest will be on a 30-year fixed mortgage at 5.25%. How much is the down payment? So 10% of 200,000 10% as a decimal is 0.10 of means to multiply. When you do that, it is $20,000. So you have to pay $20,000 up front, and then your loan does not include that $20,000. It is the $200,000 minus the 20. So $180,000 for the loan. What will your monthly payment be? Well, monthly payment is formula number 9. So formula number 9 says PMT, the payment, equals P times R over N, all divided by 1 minus 1 plus R over N raised to the negative NT. So the P here, the principal of this loan, is the amount of the loan, the $180,000. The rate was 5.25%. So I'll change that to a decimal. We're making monthly payments for our mortgage, so 12. 1 minus, parentheses 1 plus, that R over N, all raised to the negative 12 times the T for this mortgage is 30 years. So times 30 in parentheses. When you plug this huge expression into your calculator, you should get that the monthly payments are going to be $900 or $993.97. Hopefully, what you have realized about all these formulas is that they're all interconnected, and if you understand how to plug in and you know how to put it into the calculator, there really is nothing else to worry about. These problems can be made more difficult than they are, but if you have the formula sheet and you know what the letters are representing, it should flow into the formula. D says how much interest. That is formula number 11. So you take the total of all your payments minus the loan amount. So on this one, each of the payments was $993.97. You did that 12 times a year. So that would be for a full year how much you would pay. And then if you multiply that by 30, you get the amount that you're going to pay for all 30 years. Well, I take that total minus the amount of the loan, and I'll get how much of what I paid went to cover the interest. And when you put that in, you have to excuse that mutt in the back. We get $177,829.20. This is just about the same amount as the actual loan. So you think you're buying a $200,000 house. Well, in the end, you're actually paying $357,000 for it. So better enjoy and save up. Okay, last one. If you're going to spend that much on a house, you better have a car too. So, two different options for a car. One is that we can buy a car that costs $20,000 with a 5-year loan at 3.25% interest. Or we could buy the same car for $24,000, but this 5-year loan won't have any interest. So we want to know, is having no interest enough to cover the $4,000 difference in the price of this car? So we want to calculate how much is the interest for that first car. In order to do that, we'll start by finding the payments that we would have to make, and then we'll find the total amount for the car. So the payment using formula number 9, the formulas for cars and homes are the same. So that's why I put those two sections together instead of spreading it out and making it more than it needed to be. So we have here the P is 20,000. The rate is 3.25% monthly over 1 minus 1 plus 0.0325 over 12 raised to the negative nt. And t is 5 years here. So the payments here, when I put that in, are $361.60. So if I do that every month for 5 years, so times 12 months times 5 years, how much interest am I going to have? Well, that's the total amount that I'm going to pay on this car. If I subtract the 20,000 that actually goes to the cost of the car, it gives me $1,696 that goes to interest. So having interest on that $20,000 loan, yeah, it racks up another $1,700, but it's not the $4,000 difference. So the option 1 is actually cheaper.
Yep.
It's cheaper overall.
Wow.
And if the monthly payment were calculated for option 2, so you would have $24,000 broken up across the 5 years. 5 years times 12 months is 60 months. So if we divide the 24,000 by 60 months, it gets us $400 monthly. So you pay more per month, and it ends up being about $2,400 more overall. Sometimes car dealerships will give deals like this, and if you aren't calculating this out, you might just end up paying more because the deal seems good. So always think through the math. Okay, so that covers everything in the practice exam. Do we have any remaining questions, concerns at the moment?
No.
Anyone questions about what the exam will look like or any of the material?
Yes, what will the exam look like?
So it's going to look a lot like the My Math Lab assignments, but you won't have any of the helps, and the browser will be locked down just like the lockdown test was. So if you haven't done the lockdown browser test, you absolutely must do that to make sure that the browser is going to work for you and that you can take the test. If you don't have it, then the test won't even open. If you get kicked out of the test, you can't go back in without emailing me. It will require me to get you back in. It's just kind of to make it a secure test environment so that you can't look at other sources. The only thing that you're supposed to have out is your calculator and the reference sheet, and you can make notes for like percent formula and things like that, like you would a regular test, but you shouldn't be browsing to other sites or anything like that. That's the idea. Anything else? Okay, well,
Thank you.
you're welcome, guys. So your test is going to open at 4, and you have until May 1st at 8 p.m. to have it finished. You're allotted 75 minutes to work, but it's not going to take you nearly that much. But just in case, I recommend that you not wait until an hour before the deadline, because at 8 p.m., it will cut you off whether you're finished or not. So give yourself enough time, especially if you might have some technical difficulty. I had another class take a test, and about 4 of them got kicked out, and some of them waited until the last hour to test, and instead of 75 minutes, they got about 50. So please don't let that happen to you. But otherwise, you can email me if any other questions or concerns come up, and I will get you the answer key so that you can work through it more slowly and absorb it all better later. Is there anything else before we call it a day? All right. See you guys. Good luck on the test.